Our next presentation is going to be about MAIA Util, an NPM package for bridging web audio with music-theoretic concepts by Tom Collins and Christian Coulon.
Thank you, Jesse. Hi, everybody. I'm at University of York and MAIA, and Christian is at University of California in Davis, and also MAIA. So here's what I intend to present to you this afternoon. Firstly, since I haven't been to Web Audio Conference for a couple years now, I thought I'd tell you what MAIA was, what we've been up to, and what our motivation is. Then I'll move on to specifically what the paper's about, a package called MAIA Util, and then look at some potential applications of it. I'll just put a quick plug in. We, the University of York, are currently recruiting PhD students, so if you're interested, I'll put my email address up again at the end. Please feel free to come and speak to me or email me, and we can discuss potential topics. Okay, so what's MAIA? It stands for Music Artificial Intelligence Algorithms, and if you look in the bottom right in kind of the right way, you could perhaps figure out MAIA. That's the homepage. It's a music cooperative, which is a way of saying it's a kind of a very left-wing type of business. Firstly, it doesn't make any money at the moment. Secondly, the idea is essentially an exercise in the redistribution of wealth. So we're trying, from an academic point of view, to model how people are in myriad ways contributing to pieces of music and songs, and then should that music ever make any money through advertising revenue, etc., we will have decent models in place for how to distribute that fairly, especially when the music has been created collaboratively, when it may have had some technological input in terms of the algorithms behind it as well. But perhaps a simpler way of saying what we've done so far is that we've built some online spaces for collaborative creating, for sharing, and for understanding of music. So what's the motivation? It's three-part. The first one is maybe self-explanatory, but I'll give you a quotation in a second. Music for all is one of my personal motivations. The second one is that I would put some money on the future of music being this kind of confluence of consumer and creator. We've heard echoes of that already in the conference. And then lastly, from a research point of view, I'm really interested in how people come to be good, quotation, at making music. I was, quite good at imitating different composers when I studied music. Hundreds of students pass through and acquire expertise in that every year, either through instruction or through finding their own roots. So I'm kind of interested in how that happens. And so one of the first things I'll show you is a web-based DAW that Christian and I and some students built specifically with that aim of kind of trying to dig into the evolution of music composition in mind. Anyway, music for all. If you don't know what I meant from the first quote, it's the idea that everybody, irrespective of material wealth and background, should have access to high-quality music and audio technological experiences, which may lead to their intellectual and or social enrichment. The idea is not new. This isn't a typo. This is from, it's not a quotation from this paper, but this is basically someone from Victorian Britain saying, hey, we should teach music in schools. In one of the presentations yesterday, we saw the second quote here, this kind of idea of democratization of audio development, and then something else I found on the topic, producer plus consumer equals prosumer. So this is, the idea that it's not just a one-way pipeline nowadays, but all sorts of confusing and exciting things are going on in terms of creative flow. Now this isn't a very nice looking interface, but what it will show you is the evolution, and it doesn't have any sound in this one, but the next bit will. This is me grabbing someone's activity in a web-based DAW that I'll show you in a second, and basically speeding it up by a factor of 20. And time is on the x-axis, MIDI note number is on the y-axis. All instruments or tracks are projected onto the same grid, so it's a little bit messy. It comes from two people working on an EDM loop. I think in this experiment they worked on it for 20 minutes. But just to give you an idea of the type of data I can look at on the back end of the DAW. So I select participant, speed up factor, and now I'm looking at what they did and when. So it's a pretty brief example, and we can't play this in the moment yet, but for this kind of short content, you can kind of just listen to the final thing and then kind of reverse infer what was going on in particular moments. What I noticed looking at these is there are kind of quite clear action and appraisal cycles. And I've done a fair amount of EDM loop writing as well myself, but I never really reflected on how I did it. But there's clear passages where they're listening either to themselves and what they've just done, or they're listening to their co-creator. And then there's intense activity, which is the action phase. Anyway, that's where I would like to go. These are the students who 2 summers ago, maybe 3 now summers ago, helped Christian and I build it. This is our main tester. Previous talk also mentioned family testers, a good source of testers. And Christian wasn't pictured previously, but that's Christian there. We built it while I was working at Lehigh University in the US. Let's have a quick look at it now. Okay, so let's just risk reloading it. So you have login and stuff. I've called myself Wolfgang Amadeus Music, but you don't have to be logged in to do stuff. And I'm just going to show you, I suppose let's go from here.
It came with the break of day, had to run away. Baby, I can't stay with you.
So it's kind of clunky, but you can do good stuff in there. If you want to have a quick play around with it, I put a bit.ly link for this, which has disappeared from the title. Let me just recreate one quickly, maybe. Oh, it already has it. Okay. So you can try and break it for a minute or 2 now if you like. I'll just put it here. So if you go to that bit.ly link, it should redirect you to the page that I'm looking at right now. And it's going to work either in Chrome or Firefox. Playback is broken in Chrome. Nobody bothered to fix the audio context error in Chrome. But I don't necessarily want you to be playing it back on your own computers anyway right now. But there's somebody just joined. That's great. I put some Radiohead in here. So we can start destroying it. Like this. There we go. Good. Yeah, the drum stuff is going to be down here. You can put drum stuff up there, but it was going to just create an error message.
Sorry.
Can add an instrument.
Sorry.
All right, you get the idea. Thank you for contributing. So that's Jam, built by MAIA. What's MAIA Util? So, thank you. So I'm 10 minutes in, Jesse. Okay. So there's all this exciting stuff going on, right? Loads of stuff going on in web audio, in music information retrieval, or MIR, in music cognition, people doing a lot of stuff on various experimental approaches to how people perceive music, but also developing computational models of those human behaviors and of the kind of neural functioning, and then in computational music theory as well. So I don't, by putting MAIA Util here, mean that this is going to solve all the problems and bring everything together and it's going to be great. It's in a way a very small contribution, but it can build bridges between some of these domains, as I will show in a second. And we had a presentation from Luis earlier on Essentia.js, which to some extent might remove some of the need for me to think about these upper boxes, upper circles, and I can just use Essentia.js to do some of the things which previously, in some of these examples, I will have done in offline using Python packages. But anyway, this is the main takeaway of the paper, that we're trying to provide some glue or some bridges between these separately exciting domains. What is MAIA Util? Technically, Node Package Manager package. You can find it by searching MAIA Util on npmjs.com. If you want to use it server-side or as a kind of JavaScript scripting language, which I do quite a lot, just require it once you've installed it, or get the latest version from here and copy it straight into something you can refer to on the client side. Why did we develop it? Christian and I and others have, worked on a number of prototypes, and then we just kept reusing stuff and it was getting annoying, so we packaged it up. And the code isn't great, and it definitely needs a refactor, but we felt it was time to share back and see what other people made of it. So let's look at some of the things that you can do specifically with this package. We use this quite a lot in Jam. So to explain briefly what I mean by symbolic time conversions, musicians will tend to talk about things happening on certain measures in America, bar. In the UK, I'm not sure what the language is elsewhere, but you've got like a bar and beat number where things are happening. Typically for analytical or generative purposes, you don't necessarily care about bar and beat numbers. You want an incrementing measure of time starting at 0 for bar 1, beat 1, and just going up and up and up. But you don't necessarily want to store duplicate information or information that can be calculated from other information on your database. So, converting between these is something we do a lot. It assumes that you have one or more time signatures. So, like, if you've got 4/4 time, and that's all that happens because you may be doing EDM, then that's a very simple variable that looks something like this. Bar number 1 starts in 4/4 time. That's it. But if you're doing something where the time signature changes, for example, here, then we might need to manage that a bit more carefully in terms of figuring out where this starts. It's easy to see it's like bar 1, 2, 3, 4, beat, not beat 1, but beat 1.5. So bar 4, beat 1.5. And so what you can do with the utility package is kind of send that information in with the time signatures variable, and you'd get out the answer 10 there, or you can go the other way around, send in 10, and get out the answer of bar and beat. So that's a very basic one. Something slightly more exciting, take audio as input, use somebody else's multi-F0 beat tracking algorithm, quantize the stuff that's coming from that, and then do all manner of things. The point of this slide and this particular application is that you essentially cross that audio symbolic divide, right? And so you can do really exciting things when those two worlds can talk to one another, most ordinarily in the audio to symbolic direction, and then you live there, but potentially you could go back the other way as well, I guess. So I will maybe gloss over the technical details of what's there for that, but just show you the web-based demo of it. I used Free Music Archive, scraped from 2016, Multi-F0 from Hawthorne et al., beat tracking from Krebs. I did that offline. It's important to say that because the demo makes it look a bit like it's happening in real time, but it isn't. So let's start with this super simple one. Turn it down a little bit. So just an ascending guitar scale. You can see how good or not the multi-F0 estimation and beat tracking is there. And then what I'm just showing here are some histograms that are calculated in real time, showing the distribution of on times across the bar, and then MIDI note number material here. I can maybe look at one slightly more complex one. I need to tidy this up and give a student credit who worked on it. But this is a more elaborate piece of music here. All right, that's probably enough of that one. So the main other thing I've done is provide some ways that you can not annoy musical users. Does anyone want to tell me what's wrong with this? Yeah, it should be B flat. So if you recognize that, then great. If you didn't, then we're perhaps also misleading people who are trying to learn about music. Whether or not you would actually say, okay, this is in F major and put F major in the key signature is, to be debated, but the context is probably F major and this should be a B flat. So that's one other thing that's in there. It's quite complex how you do that, but the research is quite old. There's like cognitive algorithm for key estimation, and then, already over a decade old algorithm for pitch spelling. I actually implemented something simpler than this one, but it uses something that Meredith talks about, which is the morphetic pitch number. And I think that's probably worth pausing on, because what we know when someone plays something in is the MIDI note numbers they're playing, right? And that's why we will misspell sometimes B flat as A sharp or vice versa, depending on the context. Meredith points out that there's this bijection between a morphetic pitch number, which is numeric height on the stave. Once you know that and the MIDI note number, you can unambiguously get the pitch class and the octave. And in the other direction, if you know these two things, you can get these two things. So there's something in there as well for that. And then what I wanted to show you there was kind of putting that together. We can do kind of instantaneous key estimation and visualization. So it's making me a gray triangle at the moment because I'm not playing anything, but if I start, try and do some G major stuff here, we'll get a G major color key. If I switch to A flat, it should start going blue. And if you play A flat longer than you played G major for, the blue will kind of ascend to the top of the hierarchy. So I will kind of bring it to a close. Future work is slots. If anyone's interested in playing Muse in the jam, I like Muse. Thank you for your attention and look forward to your questions.
All right, do we have any questions? I wanted to go back to that very beginning where you had that demonstration where you watched people compose and you had the pauses that really meant that they were listening, reflecting, or thinking. And I was just curious what your thoughts are about that. And when you did the jam together, it was kind of a similar situation.
Yeah, so it's a good question. I mean, part of it might be to do with the fact that it was looping music, and so you were forced, if you wanted to kind of wait to hear something, you had to wait. So I suppose it makes sense to also try this in a, like a compositional setting where you're either limiting people's ability to loop it, or you specifically tell them you can only play from the beginning, to try and tease out the difference, that might be creating. But yeah, I think basically what people are doing, and I haven't really noticed myself doing this when I compose, but I think, they are listening and then they're having a burst of...
Do you feel like the collaborative side of things interferes with that?
Yes, that's a good question, actually. So if I use the drop-down menu and pick a solo effort, which we ran in the same experiment, we see the same quite distinct. So yeah, that's there irrespective of the collaboration, but I'm not sure in terms of quantitative measures whether the collaboration increases that. Yeah.
Any other questions? All right. Well, thank you very much.
All right.